And so again, we see that this arrow pushing mechanism tells us the how of what we know happens
what
in the reaction.
it end up looking like at the end of the video. You can see that they're getting this mini lecture. They're seeing the author on screen. They're having an opportunity to hopefully have what was written in text explained in another way. What might look like a lecture. The difference is, or what might happen in an office hour. The difference is that can happen at any time. And so this, it effectively, it gives them another opportunity to engage, and we'll talk about how we use the Lightboard technology later on. So let me jump back into the PowerPoint, and we're back on PowerPoint. Yes. Okay. All right. So the second one that we look at, and the one that I actually like the most, because I think students that are going to do the work will need this most, is this idea of working lots of assessments leads to the improper use of answer keys. And this is one that actually, even if you don't have organic chemistry knowledge, I think, or not having organic chemistry knowledge might make this point even more clear. So here's an assessment. The students, what we're imagining a student working 8.31a, doing part I, or part 1, and part 2. And so shown here in the center of the screen is the answer that the student might put. If there are any organic chemists in the audience, they'll know that those are incorrect answers. But if a student uses a solution manual and they've drawn these two answers, the standard answer key that just shows the answer to the question is going to have molecules that look like this. And now, if we think about what this looks like, right? If this is a 5-membered, right? It looks like a pentagon, and the student has a pentagon. It's got a line coming off of here that we know to be a methyl group. We've got a line coming off of here, and we've got a bromine atom. We've got the Br. The only difference between the two of these is that the bromine is in a different place. And so for a student who's just starting out learning organic chemistry, they quite reasonably could look at their answer and the correct answer and say, okay, I'm incorrect, but man, I'm like 99% of the way there. The only thing is that I've got the bromine in the wrong spot. And so that's going to lead students to believe that they understand the material way better than they do, because the concept that dictates where the bromine goes is a really important concept. So this reaction, the answer that the student has come up with, looks like it's close to correct, but it's really not. It's missing a really important concept. So a standard answer key isn't really going to show that student what they're missing. A slightly better answer key would be one that actually shows how the problem would be worked out. So gives a mechanism, a little bit of a problem-solving process, so that maybe the student could observe what's going on. I think a student that is a novice organic chemist might look at this and say, okay, well, it looks like we need the positive charge to be here. Okay, maybe they get something out of that, maybe they don't. And so the question is, if we want students working problems and they want to have solutions, what's a better solution manual? And this, I believe, is the better solution manual.
This assessment asks us to predict the product of the reaction of the same alkene with HBr.
Oh no, sorry, I just did that 3 times in practice too. Let me restart that.
This assessment asks us to predict the product of the reaction of the same alkene with HBr and HCl. As always, when we're predicting a product, we want to do this by drawing a mechanism of the reaction. What we recognize is that the alkene is nucleophilic and HBr is a good electrophile. And so we can show an acid-base reaction where the pi electrons grab the proton, kicking out Br-. This is going to result in the formation of a tertiary carbocation. Why? Because the tertiary carbocation is more stable. We could have also used our bouncing arrow to show formation of that tertiary carbocation more clearly. By starting in the same spot, we can have the electrons bounce through the secondary carbocation and attack the proton there. This makes it clearer that we're forming the new CH bond at the secondary carbon, and the tertiary carbon is becoming the carbocation. The other product of this reaction is Br-, and now we have the standard negatives attack positive situation where the lone pair is donated to the tertiary carbocation to give us the following product. Action mechanisms, regardless of which reagent we used. To complete this, let's go ahead and show the bouncing arrow that we might have used down here in the HCl reaction. So once again, we can have those pi electrons bounce off that secondary carbon.
All right, we'll stop there. But the point here is you can see how this solution manual is going to be way more effective, because at various points, the author, myself, the teacher on the screen, the person that would be present in office hours, is pausing to say, and here's why we're doing this. Here's how we made this. Comparing this to an answer key that only shows one molecule or only shows the mechanism really misses the opportunity for real student learning. A student that, and it's true that this is going to take a little bit more time, but a student that watches this video, and again, on 1.5 speed or 2x speed, the students are really used to doing that. And they even have a program where you can take the squeakiness out of the voice when watching it on the 2x speed. It ends up being time way better spent, because at the end of this, the student knows, okay, not only was I incorrect, I know why I was incorrect, and now I can take that knowledge and use it to work the next problem. In that example that I gave at the beginning, where if a student works this problem on a Saturday night, then they wouldn't find out the real office hour answer until Wednesday. They're going to find it out right away, and they can continue building on that foundation of understanding, as opposed to a foundation of misunderstanding. It's kind of convenient that this follows the Steve's presentation on Chegg, because one of the questions that I'm a notorious Chegg hater. My book was actually first published on Chegg before Pearson had a chance to publish it. There were actually assessments that had been put on Chegg. So I have a big problem with Chegg, and one of the things was, how do we prevent this from becoming Chegg? And what we've essentially done is we've placed every in-chapter problem, at least one part, is on the YouTube channel. So right now, these assessments are all accessible on the Organic Chemistry by Mullins YouTube channel. My son is super disappointed that we only have 141 subscribers, but remember, the book has only been out a year, and so hopefully that subscriber number is going to shoot up, lest he be ashamed in front of his YouTube community. So we kind of limit the number of assessments, but all of them, there's at least one part of each one that's present, so that students can get access to that information. The hope is that it would make that dialogue during office hours or with study groups, recitation sections, much deeper. Now, how does the Lightboard work? So if you're not familiar with the technology, this is my colleague, Adam Osman, who actually contributes to some of the videos within the key concept videos and the videos on YouTube. And what you can see, we're kind of taking the view that the camera would be looking at from here. And so you can see Adam writing, and notice that everything is written backwards. So the camera initially is going to see everything that he does as backwards. Adam is right-handed, but he's writing left to right. And so the camera is going to see that. There's software in the computer that will flip that image, so that now the words are written correctly, and the words are written left to right. If you remember from the video of me, I was writing left to right across the screen, but I looked like I was writing with my left hand. I'm actually right-handed. So the image of me is what ends up being reversed to ensure that the words can be seen as we read. And so here's a picture of that. So the camera is back here behind this monitor. Notice that Adam is writing on a blank piece of glass, but on the monitor, you can actually have overlaid PowerPoints. So by overlaying PowerPoints, we kind of have this weather person effect, where we're kind of moving around the screen, so you can annotate figures from the book, annotate charts, graphs, etc. Adam had even figured out a way to take some molecular modeling programs where you can kind of view things in 3D on the screen, and standing behind can point. So gives you an idea of some of the capabilities that this technology enables. Just to go through the specific equipment, talking in a little bit more detail in case this is something you might be interested in. At Xavier, we have our own studio for the Lightboard. It's just a sound studio that we can use for this. So here is the Lightboard shown here. You'll notice there's a black curtain in the back. The room is completely soundproof and completely painted in black so that it can get full darkness, no light at all in the room. The light, there's two sets of lights on the glass. So these lights here are meant to illustrate or to highlight the person that's drawing. So these are the lights that make the person visible. And then if you look closely over here, you can see these kind of LED lights that are embedded in the glass. So everything we do, we write with fluorescent markers, and the LED shining into the glass helps those to light up so that those stick out. This picture here, if you had this view here in the bottom right, that's the camera that you would be looking into, and here is the screen. We use this one button studio software from Penn State, but this is where you would see what you're actually writing and what the camera is seeing. The setup of the room, again, just to kind of give an idea of what it looks like, we've got the black curtain in the back. We've got soundproof black walls all the way around, the Lightboard here, the television and the monitor so that you can see what you're drawing. One of the challenges is there can be a little bit of a delay. So with that weather person effect, it can get a little bit awkward at times. But the nice part about these videos that I'll talk about in just a second is the production requirements are pretty limited and they're not too extreme. And I think that actually is a selling point of these videos compared to ones that might be much more professionally done with publishers involved. The key concept videos that we did, the publisher was involved in, but as yet the publisher's not involved in these YouTube videos except for giving permission to use the images. And so the turnaround time for production is much faster. And then over here is a computer that's going to kind of capture all the recordings and allow us to change the settings. So what the benefits of the Lightboard technology as used for the solutions manual on YouTube, they kind of can become interactive. So over the course of the last year where people were first adopting the book, I actually had conversations with a few students through the YouTube comment feature where they would actually post and reply to a video. Hey, I didn't understand why you did this thing. I would respond, they would respond, and everybody else would be able to kind of see this dialogue. The other thing that happens through that interactivity of the comment feature is we do make mistakes. As I said, these videos have low production cost and relatively low time intensity. So there was one situation earlier this semester where a student noticed that we had added one too many carbons in one of the videos. I got that message at noon, went over to the studio by 1. By 1:30, we had a new video replacing it. So because it's not involving designers and all of the really expensive people that publishers would pay for, we can get the videos up in relatively short order where mistakes are made. The obvious benefit is that students get immediate help. Again, it's kind of office hours on demand for any assessment that they're struggling with. They can get help for at least part of it. And by only having the first part, for example, let's say they did that 31A, now they can go and work 31B on their own and still able to check their answer with a more traditional solutions manual. And if they miss 31B, now they have something to have a conversation about in office hours. You'll see tomorrow, if you come to tomorrow's presentation, I talk about how a textbook can develop a rapport, or how I hope a textbook can develop a rapport with students. This type of technology allows that to happen really well. So the students can see and hear the author. It's not Khan Academy style where they're just seeing structures on the screen. They're actually putting a face to this, and I think it humanizes the author in a way that can be positive, increasing the engagement beyond, as I said, just words and pictures on the screen. The other thing that they can observe, the students get to observe problems being solved, hear explanations, and see what I've called pause points. What I mean by that is there are times during a video where even as a content expert or a supposed content expert, where we'll pause or maybe we'll draw something wrong and we can say, oh, never mind, erase that. and just keep going. And the publisher, when they first saw things like that, they said, oh, we can edit that out. The students actually don't want that edited out. They actually benefit from seeing experts make small mistakes. We fix them right away, but they actually value that. Oh, if the author can do this, if the author can make a mistake, then so can I as a novice. And I think that getting rid of that that high production quality where everything has to be exactly perfect, it helps, again, humanize the interaction. And then if there is one where a mistake is not noticed, like I said, we can very easily replace those. That's essentially all I have. I do want to give an opportunity for questions. If you're interested in the Lightboard technology and how you might use it for yourself, I've put my email address on the screen, so feel free to reach out for that. But I'm happy to answer questions you might have.
We just have about 3 minutes left, so maybe one or two Go ahead and speak up if you have a question.
Rick, in terms of capital cost, were you able to get a grant, or did the university set it up?
Yes. So actually, the university was planning on doing this, and then Pearson saw value in our university having it. So Pearson did contribute to Xavier. So there's a couple of grants. Xavier was doing it, and then Pearson made it. Donation may not be the right word, because I'm not sure what they're legally allowed to do, but Pearson provided funds to help build the studio.
Okay, well, Rick, this was an excellent presentation. I can see how there are a lot of different disciplines that could benefit by this. And Danelle in the chat pointed out that your process of humanizing the instructor and the textbook author is often called cognitive apprenticeship. So another case of learning a lot from the presenter and having contributions from the participants. And one of the many things that Rick, you and I both love about TAA